We are moving to section 5.6. 5.6 is focusing on inverse trig functions, another oddball function that just kind of gets lumped into chapter 5 because there's nowhere else to put it. So first, I just want to talk about just representation notation of inverse trig functions. So when you talk about inverse trig, and it can be done with any of the 6 trig functions, inverse sine, cosine, tangent, etc., there's a couple ways to write the notation for inverse trig, and they're both used, and I want to make sure you recognize both. So the notation that you probably remember with inverses from just algebra classes is putting the little -1. So if I wanted to say inverse sine, I put sine with a little -1 kind of superscript of x. There's another way to write inverse trig, and it's with the prefix arc. So arc sine and inverse sine mean the exact same thing. Sometimes on the AP test, they'll use the arc notation just because I feel like we have so many like little symbols with prime symbols and double prime symbols that sometimes just writing it out with letters is easier to write and to read. But they both mean the exact same thing. I do tend to do most of mine in arc notation because of that reason, because I just think it looks messy with all the little superscripts and prime symbols, but it truly can be presented either way. So today's focus is going to be how do we derive? These are the final derivatives in all of calculus. At this point after today, you will now know how to derive anything that is out there, logarithms, exponents, power rules, chain rules, trig, the whole deal. So we have 6 rules. I'm going to leave this up here. I'm going to pause a little bit. If you want, you could pause the video so that way you get a chance to jot these down. It's probably the best bet. So once you have these written down, I want to start looking at common features because, again, it's really hard to memorize a list of things if we don't come up with some quick ways to notice things that help us remember them. So here's my first quick thing that you should notice, and maybe you did as you were writing them down. The co-functions are identical to their original functions. What I mean by that is arc cosine and arc sine, except for the co-ones are negative. So notice co-negative. Cotangent, negative. Cosecant, negative. So technically, I know there's 6 things on this screen. You're really remembering 3. You're remembering the ones that are not the the arc sine, arc tangent, and arc secant, and realizing that its co-function is negative. Next thing I want to look at is what else do they have in common? Well, they all have du in the top. So whatever that inverse trig is of, whatever that function is, we call it the u function, its derivative will always be part of the numerator. Now, how they differ is the denominators. We have 3 different denominators that happen here. With sine and with cosine, your denominator is the square root of 1 minus that u value squared. With tangent and cotangent, there's no square root. It's the only one that doesn't have a square root. And it's also the only one that has addition. So it's really the most unique of all of them. It is 1 plus the u squared, or you could write it as u squared plus 1 because it's addition. And then the 5th and 6th one, arc secant and arc cosecant, have the most bizarre looking derivative rule. It has the u in front of the square root. If you forget the absolute value, you're still going to get it right. And then the square root of u squared minus 1. So it does the subtraction in the opposite order as well. As you would probably expect, the likelihood of seeing this on the AP test will decrease as you go from sine all the way to cosecant. Arc sine and arc cosine could very well show up. Arc tangent may show up. Probably the bottom line won't. I would say that if I had to bet on the likelihood of what you would see, I would really focus on those top 3, arc sine, arc cosine, and arc tangent. I've also noticed on Delta Math, those are the 3 that they focus on, which I appreciate because it's pretty authentic to what you could see. So we're going to take these rules and we're going to derive them. It is nice if you have them somewhere on a piece of paper that you can use it as reference as I'm talking, or even as you're doing your homework, just having that list of 6 next to you, or at least the 3, and knowing that the co's are negative. So we're going to do really basic ones. We'll do ones that have a little extra work just so you can kind of see the variety, and then we're going to finish with a couple questions that are on Delta Math. So your derivative, your numerator will be the derivative of this. That is your u, so the derivative of 2x is 2. And then your denominator will be the square root of 1 minus this squared. So you can put it in parentheses if you want, or if it's really easy to square out, you can do that as well. We're not really going to do much with simplifying until I get to the very end and we start talking about actually plugging numbers in. The second one, the derivative of this is 2e to the 2x. The bottom of arc tangent is the only one that doesn't have a square root. It is 1 plus this squared. When I square e to the 2x, I get e to the 4x. And that's it. Again, these two are just showing you kind of basic, just kind of plug and chug. Next one, arc sine. Again, arc sine I'm going to probably do more than anything else. Arc sine, the derivative of this is power out front, power 1 less. I'm going to show you how to clean that up in a second. And then in the bottom, it's going to be 1 minus that squared. When I square x to the 1/2, I just get x. I don't really want to leave a negative exponent in my answer. So here's the cleanest way you could write that. You could bring the 2 to the bottom. You could bring the x to the 1/2 to the bottom, and then put it all next to the square root of x minus 1. You could also write this as 2 square root of x times the square root of 1 minus x. So there's a lot of ways to write that that would all be correct. I'm mainly just looking at moving the negative exponent to the bottom. Arcsecant, derivative of 3x is 3. So this is the one that's a little strange. It has the u in front of the radical. The absolute value bars will really only come into play if you're actually plugging a number in for x. It just ensures that it's positive. And then under the square root, you do u squared minus 1 instead of 1 minus u squared. So that's going to be 9x squared minus 1. You can leave it like that, or if you want, you can cancel the 3's. So you could all go a little simpler and write it like that. As you would expect, you can take these rules and mix them with other things. So product rules, quotient rules, all of those things are fair game. You don't see a lot of it. I feel like when they ask you to do inverse trig, they try to limit the other stuff that they make you do. But this is a product rule. I feel like product rule is the most common extension. So for your product rule, first times the derivative of the second. So the derivative of arc sine of x is 1 over the square root of 1 minus x squared, plus second times the derivative of the first, arc sine of x times the derivative of x is just 1, and you can leave it like that. So even though it's kind of a long-looking answer, there's really not much you can do. So as I went through Delta Math and tried to see, like, other than what I just showed you, what else are they going to ask you to do? Well, what I noticed with the basic derivatives, where you're just deriving it in terms of x, they tend to be pretty straightforward. I did not notice a lot that combined a lot of rules, which is great. If you are asked to go a step further, they will give you a value to plug in for x when you're done and ask for your answer in simplest form. And that might be the toughest part, is kind of the algebra at the end. So I wanted to do 2 with you. So for this one, it is a co-function. So first thing I'm going to write down is a negative, or else I'll forget. The derivative of x is just 1. So I have a negative 1 on top, or you could put the negative out front. And then under my square root, it's going to be 1 minus x squared. So now I need to input, and here's where I think it gets a little messy, 1 minus, when I do the square root of 15 squared, I'm going to get just 15, over 4 squared, which is 16. So I get 1 minus 15 sixteenths, which is 1/16. That is a perfect square, and that shouldn't surprise you. If they tell you to do it in simplest form, it's probably because things simplify maybe even more than you realize. The square root of 1/16 is 1/4. You can just square root the top and square root the bottom. And then when I multiply by the reciprocal, I get -4. So you can get a lot of these very, very simplistic. If you want to use a calculator at the end, no problem at all. I would just be careful with the square roots. I really wouldn't use much for a calculator there, because I really don't want to get into decimals. So if it doesn't end up as a perfect square like this one, kind of stick with that square root, that exact notation. Let me show you one more. I cycled through a ton of them on Delta Math, and the common theme was arc sine, arc tangent, arc secant, or excuse me, arc sine, arc cosine, and arc tangent were the ones that kept showing up over and over again. I feel like sine and tangent are probably the most common, which are great because they're the positive ones. So the derivative of arctangent is 1 over, it's 1 because that's the derivative of x, 1 plus x squared. So very, very quick derivative. And then you're going to put in your value for x and square it. So you will have a lot of things that start with a square root, because when you plug them in, you're going to get squared. So you're going to have square root of 21 squared is just 21, over 5 squared is 25. So what do we get here? We get 1 plus 21 25ths, which is going to be 46 25ths. Make sure I did the mental math right. So this would be 25 over 25 plus, so 46 over 25. And then when you multiply by the reciprocal, you would get 25 over 46. Again, trying to limit the decimals when they want that simplest form. They're looking for exact answers, so fraction answers, square root answers if they didn't simplify. That's lesson 5-6. There's a lot of other like non-calculus stuff that the textbook does. It's not going to show up on the AP test. The only thing they're going to ask you to do on the AP test is either to derive and leave it, or to derive and then put in a numerical value to get a slope.